Hey, everybody. Thank you for being here today. Today's session is about operating cloud engineering at a real enterprise scale. Today, we have Alex Carraro here, as well as Tarak Bakamba, my co-founder here at InfraCodebase. And guys, I'd love for you just to do a brief introduction of yourselves. Maybe, Alex, you could start us off.
Hi, everyone. Alex Grau. I head a group of cloud engineering in a big financial organization. I've been in technology for almost 30 years, sometimes as an architect, sometimes in software delivery, and over the last 6 to 8 years, managing infrastructure, specifically on with a focus on cloud, both on the private and the public side.
Great to have you.
Thank you.
Very nice meeting you all. So I'm Tarak. I'm the co-founder of InfraCodebase, and I spent 5 years working in cloud, and I'm very interested about what we spoke about with Justin and Alex today.
Great. And yeah, super excited, Alex, to dig in today to learn a little bit more through your experience and how you've built centralized cloud teams, led enterprise architecture practices, designed reusable platforms, and driven migrations across hybrid and multi-cloud environments. These are really complex areas with a lot of regulatory scrutiny, risk controls, and governance that are not theoretical, but actual constraints and daily realities for people that work in large enterprise companies. And so I think what really makes this conversation valuable is that Alex has seen the full arc. He's an expert-driven engineering, large-scale standardization, and the limits of both. So today we're going to focus on what actually breaks at scale and what changes when execution becomes the priority for companies who are operating the Hey, sorry about that, Alex. My bad.
You were frozen there for a minute.
That's okay. Look, I'm unfrozen. So anyway, so kind of back what we were saying, you've seen the limits of both, of those things. And today we're going to focus on what actually breaks at scale when those changes happen and execution becomes the priority. So a lot of different topics today, but want to go ahead and start diving in with you on a couple of different things. So first of all, we want to talk about the reality of what happens today in large organizations. So when you operate cloud engineering inside of highly regulated enterprise, complex environments, there's a lot of stakeholders, a lot of controls, a lot of environments, and a lot of governance and review layers. So from your experience, Alex, what changes operationally when cloud engineering moves from a few teams to enterprise scale in a regulated environment?
Well, the reality is many things change. Cloud becomes another flavor of the environments that the organization uses to provide technology services to the business. But because it falls under very specific regulatory constraints, the environment isn't free for all. It isn't, in a lot of cases, is not used to the extent that it can be used because of those regulatory constraints. We have to be concerned about privacy. We have to be concerned about the type of data that goes into those environments. We have to be concerned about how do we do ingress and egress out of those environments? How do we protect the boundary of those environments? So you end up with a set of policies that apply to those particular environments, and the controls that you implement to be in alignment with those policies. First, they slow down your progress because you have to comply with those. As you said at the beginning, there's more stakeholders. It's not your technology partners. It's not just business partners, but it's also your risk and control partners, and ultimately is the regulators. You do have to answer to the regulators when it comes to things like privacy and data protection, information security, and things like that. So it expands the complexity of how you manage those environments. And because we don't live in a cloud-only environment, our organizations always have to contend with what we call brownfield, which is our legacy environments, everything under the sun from mainframe down onwards to modern technologies. We have to account for the integration between that legacy environment and cloud as well. So it is not as simple as living in a cloud-only environment. You have to be able to manage your assets across multiple environments. Those environments all have to implement similar kinds of controls, but the implementation of those controls is different depending on the environment. So all of that adds to a more complex ecosystem to manage, which it slows down your progress. It makes more expensive the way we build and deploy products, and how we manage them on an ongoing basis.
Yeah, it's really interesting from an engineering perspective how those constraints can force you down different trade-off paths with how you need to optimize for cost and security and for speed across an organization at that kind of scale and complexity. Of course, that tension between security and speed does come with the cost of speed. So, right, when does execution most consistently slow down as that scale increases, Alex? Like, what do you see as maybe some of the biggest barriers to speed within large enterprise environments?
I think there are many, but some of the key ones that I've seen, especially when you introduce cloud into the mix, is that everything that we use in the cloud, every managed service, every resource has to align to the policies that the enterprise mandates. And so before we get to use any of these services, they have to go through what we call service enablement. They have to be vetted by information security, by risk and control, by all the lines of defense within the organization. So for you to get to the point where you use one of these services, say, for example, manage SQL on Azure, it's not as simple as building your Terraform scripts and you're ready to go. You have to go through a process. That process takes anywhere from 3 to 9 months right now in my organization. And that is a significant slowdown just to use a database on the cloud. So and even more tricky, if you don't do that enablement properly, every use case that you try to onboard, because every use case is probably different, every use case will have to go through a similar enablement. If you only enable the service for, say, confidential data, then once you run into a use case where you have restricted data, then you have to go through that service enablement again. So that is a significant tax
Absolutely.
that gets applied to cloud.
Yeah, like risk, security, legal, compliance, like, and to your point, if you scope it down to move fast now, you actually slow yourself down later because now you've sort of hampered yourself of being able to use something. And not only that, you create a really confusing environment where you have to say it's available or allowed or you can use it, but well, you can't really use it. It's sort of like you can use it over here, but you can't use it over there. And so there's always that lack of translation between business and tech. And the less we're clear about what's actually available to enable a business use case, the more difficult it is to actually like get people to use the things that we're building or feel comfortable that we can actually support what they're trying to do. So 100% can resonate with that. And yeah, definitely the process piece is typically, in my experience, slower than the tech, right? So you can really accelerate tech in some ways potentially that even process can't quite keep up with. And so you have to balance really where you invest your time and optimize for within those environments. Very cool.
Yeah, I think I would say 90% of this is process.
Yeah.
And 10%. Once we go through all the process steps and we get all the approvals, the technology is the quickest part of it.
Exactly. Yeah. It's like, so you can't just enable everybody with Copilot Studio or give them Claude Code. And now you've got an engineering organization that moves 10x faster and you're delivering more outsized business outcomes because there's a whole other set of things that have to be engineered around and improved from a process perspective to really drive things in without compromising security, quality, and trust in the overall ecosystem that you built both, on cloud and on-prem. This is really good. So let's switch into like why cloud standards alone don't scale execution. Most large enterprises have really strong standards, reference architectures, policies, reusable components, but delivery still largely remains inconsistent. And this is for a lot of good reasons. You have employees who have various levels of experience. You tend to have a lot of offshoring and other people who are not necessarily full-time in your business. You have a lot of consultants who come in and even bring different practices than what you do and try to drive change as they're implementing things with you. So it's very interesting. The question I might have on this is, where have you seen the biggest gap between documented standards and what actually gets implemented? Is it these kind of problems around these various levels of experience, different stakeholders around the edges, or do you have other experiences where you say, yeah, this is actually like this actually causes the most differentiation here?
I think the areas that causes the most inconsistency is that, or the reason that we have the most inconsistency is that a lot of the implementation of these standards is still a manual process. There's been a lot of progress in large enterprises when it comes to automation of these things, to do things like architecture as code, for example. But in a lot of cases, still the interpretation and therefore the implementation of these standards is manual. And because of that, you do have inconsistencies across lines of business, across even groups within a single line of business. Architecture, having standards helps to a point. But as long as you're limited in terms of the automation of some of these things, you're always going to have differences on how they get implemented. And even though we do have controls in place as part of our integrated pipeline to ensure that we minimize the amount of issues and vulnerabilities that we introduce into the code, it's always going to be part of the overhead that we have to deal with to maintain hygiene across our environments. It's automation is a thing that that we strive for, but because of the scale, because of the complexity, it is always trying to catch up. It's never a thing that we can rely on completely.
Yeah, and I think you did a great job there, like talking about like why reusable components and landing zones and other components in the cloud and on-prem still produce variation and review overhead for teams. And I think it's also interesting too, because you talked about the services approval process and making sure that those are onboarded. It's not always there's a point in time, right? There might be an ideal solution today that exists in a provider that you have, but it's not unlocked for you. So you make different architecture decisions around it that maybe are or are not what you'd want to do long term, but it's the reality of the current state of your cloud environment. And so, it also kind of evokes for me some thoughts around how, over time services evolve, but things sometimes will remain relatively stagnant. So you can also have kind of this timeline-based variation between what we deployed 2 years ago. We might have built differently now that we're 2 years in the future, but because of that, over time, those architectural standards change, but those resources sometimes feel relatively locked. You might have a service that's kind of running and stays there. So very interesting.
Yeah, we update our strategies on a probably about a 3-year cycle, and every time the strategy is updated, that creates work because we move away from something that 3 years ago was a standard or a strategic component is not anymore, and we got to move to something else. But that 3-year cycle is just accelerating because of the pace that technology is changing right now. It makes us make those decisions more often, which in turn creates more rework for all of the development teams within the organization.
Yeah, that's great. And it's actually a great transition into our next topic, which is the evolution of cloud engineering at scale. Many organizations evolve in phases. So first expert-led kind of execution, then shared services, standardization, but then execution often remains manual or in interpretation driven. You talked a little bit about really trying to push on the automation, and sometimes you get there and sometimes we don't get all the way there. But what do you think, at what point did you realize the core issue wasn't about architecture quality, but about execution itself and how that was controlled?
So I used to be an architect, and I still am an architect at heart. And I always had this mindset of architecture cannot be a white tower type of a job. It cannot be the perfect cannot be the thing that stops you from making progress. And I think that's part of the reason why I transitioned from architecture to execution, first on the software side of things and now on infrastructure. It's because I'm always going to keep the architecture mindset. I'm always going to want to make things make sense from a design perspective. But to me, the more interesting problem is how do you execute on it? How do you keep things architecturally sound, but at the same time you're meeting the requirements and the objectives of your business partners, who in the end are the ones who are paying for this. So that transition into execution to me was more of an interesting space. In terms of when things start failing, is when your organization sort of outgrows the boundary of a set number of folks that can all talk to each other, that can all, in a sense, be on the same page because they're either in the same room or they have a very close relationship with each other. When you go into an organization that has many lines of business with many different objectives, with many different leaders that see technology in a different way, on how technology supports their business objectives, you start getting into the area where you're going to see inconsistencies. You're going to see a lot of areas that are more focused on architectural purity. You're going to see other areas that are more focused on execution, and those are in a lot of cases they're in conflict with each other. So managing that I think one of the things for leaders in large organizations is being able to manage those differences. You're not going to have a consistently pure technology organization ever. It's gonna run at different speeds because of things like skill sets, because of even resource availability. It's going to run at different speeds. It's going to have different levels of focus on architecture or execution. So as leaders, I think that's part of our job, is to be able to manage that and still deliver.
Yeah, that's perfect. And you kind of make me think too about there's a whole layer on top of execution and engineering that's also, you get into a political realm, right? Of like all of these different places people are trying to build, everybody's trying to do the right thing. They're all trying to support the business, support the customers, deliver great value. That can create some noise and some various ways of approaching the problem from different angles. And so to your point, I think that it does create some complexity. It does create some variation. Not all of that's bad, especially if you can bring it together and kind of coalesce everybody around a common strategy and a delivery approach. But it certainly does get into the realm of politics at that point.
Yeah, and different leaders deal with that in different ways. I've seen it where organizations try to centralize everything, and that doesn't work either, because it breaks down as it goes into the lower levels of the organization. Or I've seen organizations where they try to federate everything to increase speed, which it does, but then it compounds the inconsistency problems across an organization, because even though these are different lines of businesses, we actually have to work together. They all have to work in a coordinated way.
Yeah, just even think about your Entra ID tenant or something, right? Like how you're going to federate all the identities and all these things across all of these different tenants and accounts and all this stuff. Like there's some appropriate level, it seems to me, of standardization and federation where you have to really think about. For me, it's about enablement. Like, how do we enable the business teams, the people closest to the customers and the problems they're trying to solve, to move at a certain speed, get to a certain point, and when they're ready to scale and really harden things and make things more robust at the enterprise level, to bring those in and centralize and secure. And to some of the points you made earlier around, at the enterprise level, it's not only because you're multi-cloud, but because you're international, you work in international sort of settings. So data residency, data privacy, it's great that something might be built for the US that works really great for something that we're focused on over here. But in order to truly bring that to market and to make that a scaled technology that we can use across the globe, it takes a lot of work and effort and coordination, even globally across different, components of the business to make those things work, engineering perspective, and on how you actually bring that to market. So a lot of interesting complexity built into everything that you just said there.
Yeah, I mean, we have to worry about all jurisdictions on the planet, and all the different laws and regulations across those jurisdictions, not just about the US, which only increase complexity. So everything goes against the environment in that we operate, naturally goes against speed. But we don't really have a choice. We have to be secure, and we have to move at speed.
Absolutely. And we talked about some of the complexity on that side. You also mentioned a moment ago around hybrid complexity. I'm curious about how do you see hybrid complexity change the way that you design and operate cloud platforms?
So as I said earlier, we do have to contend, and we can't get away from our legacy environment. In a lot of cases, that's by design. In a lot of cases, it is mandated by regulation. We do have to keep some things on-prem. Some of the things can go into public cloud environments, but they all have to talk to each other. They all have to, we move data in and out of our on-prem environments into our cloud environments. We also have a gigantic pool of third parties that we interact with. In some cases, those are SaaS products. In some cases, they are services that we use as part of the products that we provide to our clients. All of this ecosystem has to seamlessly talk to each other. And that means many points of integration. And every time there is one of those points of integration, that means you're going in and out of the boundaries of the organization, you run into issues like security, you run into issues like latency, performance. Some of them are technology driven, like performance and latency. But some of them are not, like security, privacy, and things like that. And you have to design for all of them. You can't just assume that a third party is going to take care of the risk. You have to design, even though things are sometimes baked into contracts, you do have to design to protect the data about your clients, because in the end, they are your clients, and they're going to come to you if something breaks. It doesn't matter if it's Microsoft's fault or if it's Google's fault. In the end, you are the responsible party when it comes to things like the reputation of the organization, or even legal and compliance issues with regulators.
Yeah, it's your brand, it's your reputation, it's your financial stability, being able to predict those types of things, all of that stuff. And things as mundane as, like, if you're hybrid and you need to change a firewall rule on-prem, right? Not everything can be automated. You probably have like Palo Altos or other things running, and you got to call a team and things have to be added in. And so, there's a lot of dreams of being able to automate everything, right, in the cloud and for engineering delivery. But the reality of the complexities of on-premise hybrid cloud environments are that there are gaps in some of the things that are easy to control, and it's on the technology side and on the people side. Like there's walls and barriers between some of these teams that operate and monitor and build up different parts of that technology estate that can really put real constraints on your ability to deliver really fast without breaking security or having to fundamentally change something that you're doing.
Yeah, and the flows that we implement, if you think of financial institutions, the flows that we operate under are extremely complex, and they can go from public environments to private environments to public environments to third parties back into private environments. And when you make a change in one of these things, there is a downstream effect. Knowing or automating what that downstream effect is nearly impossible. So that is part of the care and feeding of the environment, is to try to understand, if you make a change in one of 50 components in a flow, how is that going to impact everything downstream? And making sure that nothing actually breaks, or if it breaks, you can contain it. So that is part of the complexity that also we have to deal with. We have very complex architecture flows. There isn't anything really simple when it comes to financial institutions. And so that's also something that drives the complexity.
Yeah, what do you think one of the biggest difficulties is with scaling governance and control across on-prem and public cloud? Is there a specific pain point in between those two places that you think has the most friction, adds the most time, maybe the most complexity to working in a hybrid environment?
How you implement the controls. Because in some cases, say, for example, you're using your public cloud, your typical AWS, Google, Microsoft, even how they implement the same control, because these platforms are certified for a specific controls that are dictated by the regulators. But even how they do the implementation is different. And just saying, hey, Microsoft is certified for A, B, and C is not enough. you actually have to have your risk and compliance partners work with Microsoft to ensure that that particular control actually meets, one, the regulation, and two, the policies that we put on top of the regulation. So you have to do that for every single environment. And that creates two things. One, creates a lot more work than in a lot of cases in manual work. And two, it potentially a source of inconsistencies.
Yeah, those are all really great insights, and I love how a lot of this does not come back to the technology. It's really illuminating for folks. If you haven't worked in an enterprise environment, you're getting a little bit of a flavor of what that really feels like and looks like. So, our question here for you on innovation speed trade-offs is, how do you balance control and speed without compromising regulatory obligations? And maybe more specifically, are there specific areas where you think there are opportunities for more speed while also maintaining compliance with all of these rules and meeting legal where they are and doing all the things you need to do for global scale?
So I would say a couple of things. One, because of the scale of financial institutions, especially global institutions, not everything has to be tied down to to the nth degree. There's a lot of things that we do where the controls, whether it's by jurisdiction or by vertical line of business situation, are not as stringent. In those areas, you can definitely move at speed. But we also have, a big portion of the other side of this is where we do deal with very sensitive information under a lot of heavy regulation. And I would say in that case, automation is probably your best friend. I've heard it in some cases called, we try to do this with everything, policy as code. Eliminate the interpretation out of the equation. It's probably the best way to accelerate how you execute all of those controls. There's always going to be differences, and there's always going to be that upfront work that you have to do to ensure that if a third party it says they are certified on a particular control, that they really are. But once you do that, of course, you have to do this on a regular basis. It's not one and done. You can't just say, okay, I'm good with Microsoft forever and ever. We have this cycle of reviewing what Microsoft and Google do every 6 months or every year. But if you have the automation, and when it comes to the policies that you care about, that is probably the biggest area where you can speed things up.
Yeah, one thing I've seen being really useful recently is using Gen AI more to generate more of the things that are like important, but like paperwork that need to be done for true documentation to review a translation between like specs and like what actually needs to be implemented, because people speak different languages, architecture, platform engineering, security. And so to the extent you can use some of the internal tools you have to potentially accelerate, streamline some of the standardization of the delivery of that content, you can speed them things up. I love what you said. It was relatively nuanced there, but you said it. I think what I got from that was, if you treat every risk like it's the same level of risk, in other words, like 100% risk, then everything is going to move slow and grind to a halt. It's going to be very difficult to move forward. What the very subtle thing you said that I kind of picked up on there was like, and I totally love and agree with, is the art here is figuring out how do you actually assess the true risk of something within the engineering organization, so you can let certain things move faster that really aren't presenting you a risk and unlock that, while keeping the things that actually pose brand risk, financial risk, regulatory risk to your company. You hold tight control over those things so that you ultimately can move fast where you can move fast, and then you stay secure where you need to stay secure. So because I think one of the places some large companies fall short with lower maturity in engineering is that they just treat everything like it's a big risk. They don't trust anything. They're afraid of everything. And so like if you can start to tease that out and really create sort of a distribution of risk, now you can start to prioritize automation and where you can move fast and where you can improve your overall delivery, right?
Yeah, we call it our risk posture. And it goes all the way from the business to technology. because as you said, not everything has to be a big risk. Not everything, and there are levels of risk that we are willing to take in some cases. We can't do anything about the regulations. We cannot do anything about the compliance aspects of it. But there is a lot of other areas where we do have some flexibility. And yes, where you do not have to take a zero risk policy all the time. And that will enable you to move faster in some areas.
Yeah, I love that. Anytime that I see a big company doing really well at actually identifying where risk is and what the true risk of the business is and where they can move fast, I think it's one of the biggest unlocks that you can have is to have a really good way of measuring that.
Yeah, and it's usually a lot of places. There's a lot of areas where you could manage the risk, and it's not about not caring about the risk. It's managing that risk as opposed to completely shutting it down.
Yeah, and on the automation side too, another place that, and you probably see this, that I see a lot of acceleration is around security. I think legal and risk and compliance still is a harder process piece to move more quickly. But when it comes to security, there's a lot of opportunities, right? To use like automated scanning tools inside of CI/CD pipelines and generating standard artifacts and like trying to figure out what the threshold is. If we can cross this threshold, we can kind of move a little more freely, a little more quickly, versus needing to stop and go through some deeper review, get some authority to operate, some technology through XYZ, right? And on the engineering side, kind of to the risk side, is like, how big is the change really? Are you doing a hot fix? Is it a small thing? Are you creating a whole new feature? Is this going to break existing systems? Is it integrated with a lot of other things? So when you think about risk, there's like the technology side and the business side of that risk, as you mentioned, right?
Correct. And we use different mechanisms to assess the risk of change every time something goes into a production environment. It is a lot of overhead because just making that decision on whether this change can move forward or not in our environment is not something that you can fully automate. It'd be great if we had some type of AI helper that could tell us, yes, this change, limited blast radius, if anything goes wrong, so you can just let it go. Versus, no, this is really important. If this breaks, your entire payment structure breaks. We don't have that, and it's not a technology issue. That is one part that I think, I don't know about other industries, but financial institutions would be very, very reluctant to give to something like an AI type solution because it is the bread and butter of what we do, is protecting our client, not just money, but protecting our clients' information. And if we delegate that responsibility to either a third party or something like AI, that in itself is a big risk. And I don't think, at least for now, financial institutions are willing to take that step.
Yeah, I think about it like I use Tesla as an analogy. Like, you could have a fully self-driving car, but you always have to have your hands by the wheel and your head up, or else the car is going to go out of fully self-driving and now you have to take it over. I don't think that in any industry really that it's great to think that AI should replace us philosophically, right? Like, it should be an enabler, an empowerer, move more things into the runtime to accelerate delivery that's aligned with your enterprise and your organization. But we are humans at the end of the day, are building these systems for other humans. We're responsible for the impacts of those. There's real world impacts to the mother who needs to go get money out of the bank to like buy groceries for her kids, who can't pull anything out because the bank systems are down, right? So that this is stuff that's like really life. It could be life or death for people if things don't go well in critical industries like financial services. And so absolutely, like I think there's a lot of acceleration opportunities, but we can never take our hands off the wheel or our eyes off the road. We have to always keep in mind that if we were to get in a wreck, if we were to hurt somebody driving that car, whether we were touching it or not, that's still us. We are still the person responsible.
Yeah, you can't blame AI for that.
Nope. And it wouldn't help anyway, right? So let's talk a little bit more here about execution layers, and then we'll do a little bit of closeout here. Alex, just want to ask a couple of final questions. But if standards define what good looks like, then often the missing layer is execution, which is a place that you've developed a lot of expertise over many years. So translating intent into governed, repeatable action is really important. What does a controlled execution model look like in practice to you?
It starts with the standards, having those standards. I've seen lots of organizations that do not have well-documented standards. So it does start there, but then it flows into how do you take those standards and translate those into components, whether it is code or processes and procedures or documentation that actually goes into the products that we deliver. So having, at least in my case, having a consistent way of translating those standards into what goes into code. And, automation helps with that, but we can't automate everything. So making sure that you're organizationally, you're set up for that consistency to be there is to me is a key part of development organizations being successful at delivering and maintaining the health of the environments that they own. Part of it is also having a high performing development organization, which is difficult in today's environment because of how fast everything moves, and how I'm not going to say fungible, but how the skill sets can take people from one place to another. It is difficult to maintain a high performing set of folks, but at least that is one thing that I try to do, is focus on having great resources that understand what the strategy is, that can help translate those standards into actual components. It is also, there's many components to it. Culturally, you have to have that mindset across your organization, which is also difficult to achieve. We've moved in a lot of cases from an SDLC process, that is the old waterfall way of implementing things, that was very gate driven. We've moved into agile type developments, which helps with speed, sometimes doesn't help with consistency and quality. And so keeping that balance is part of what I think my job is as a leader, is to try to get that balance right.
Yeah, and on the consistency and quality front, I actually want to come back to something really important you said earlier and tease that back out for folks, which is around policy enforcement. I think there's a lot of focus on like automating and delivering the thing that we're building right now. But there's also this like living structure that can sit on top of your cloud or your other systems where you're consistently monitoring or preventing actions from happening in those environments. And so I think a really important story here too, which you kind of alluded to earlier, is the execution layers in practice. A part of that is the actual execution of the delivery of the things, as well as the team and hiring great people and retaining that talent, as well as the policy enforcement. Because, if you can sort of like, we trust you to do it right, but also can we kind of ensure that at some baseline level, we're going to only get acceptable results. So how does automated policy enforcement for you change the role of engineers and reviewers, or how do you focus your time on automating something upstream versus preventing something downstream? Where have you seen the most value there?
Well, it helps developers, not just developers, but primarily developers, focus on solving the business problems that are actually the value that we provide our partners and our clients, as opposed to having to spend 50, 60, 70% of their time fixing the issues that prevent them from putting a piece of code into a pipeline. I was actually not too long ago focusing on how do we prevent developers from having to deal with false positives that come out of the scanning tools. I was looking at the metrics and seeing that some developers were spending up to 3/4 of their time fixing or articulating why an issue identified by a scanner was a false positive. That's of no value. That's of no value to me or to the enterprise.
No.
Automated policy enforcement helps tremendously with things like that.
Awesome. I love it. Look, I think we've covered a lot here. I'd like to maybe go ahead and start wrapping up and get some thought leadership from you if I can. So at scale, cloud maturity becomes less about architecture patterns, more about predictable execution inside of a complex organization. Standards are at the front, execution at the back. I'd say if you're advising enterprise leaders today, what would you prioritize first to make cloud execution more predictable?
I would say the first thing is to think about why cloud is important to you. When I first started in the cloud sort of journey, it was because we were going to reduce cost across the board of everything because it was cheap. We didn't have to maintain any of it. Well, it turns out that's not the case, especially in highly regulated large financial institutions. That is not the case. So have to think about why you're using cloud. Have to think about how is cloud going to integrate with the rest of your systems, and is that going to improve your speed? Is that going to slow you down? And then think about also how you will manage the risk of using somebody else's infrastructure, which is basically what public cloud is. So if you go into a cloud journey, knowing sort of the parameters and the levers that you can use, I think you can be successful at it. If you go at it with the mentality of I'm just going to reduce cost across the board, that is probably a disappointing. Is going to be a disappointing journey.
Yeah, I mean, the cloud at its best should be an enabler and like a force multiplier for organizations to be able to do stuff. And I think the planning around how you actually do that is really important before you go into the execution, because to your point, you'll easily get results that are not what you were expecting or desiring out of that journey into the cloud if you aren't very thoughtful about it. And even simple things like in a highly regulated environment like the ones that you're used to interfacing with. You might have a thought that by using the cloud, you simplify architecture, you simplify the service delivery, but actually in some cases you actually create systems that have to be almost more duplicative and more repetitive and more isolated, and it sort of can create cost, it can create complexity as well. So we have to really consider what those trade-offs are. I love that insight.
I mean, observability is one thing that becomes way more complex, because unless you are fully in implementing your components in a singular cloud vendor, your observability becomes not an issue, but it becomes more difficult to manage across multiple environments.
Yeah, and I know you're all about execution, Alex, and you talked about mindset earlier, which I love. I think so much of finding great talent, building great engineering organizations is really about getting a collective mindset and culture that makes a lot of sense. What's one mindset shift that leaders need to make as they move from architecture-centric thinking to execution-centric thinking?
To me, the biggest shift, and I'm going to use myself as an example of when I was a chief architect versus now that I'm more on the execution side. The biggest change is, to me, is always the first thing to think about is what you're trying to achieve versus what the design looks like. Today, I don't really care as much about design purity as I care about my business objectives and the business objectives of my partners and my clients. And that forces you to make trade-offs. It forces you to, in some cases, do things that you wouldn't do as an architect, but that makes sense in the environment that we operate, that makes sense in to meet the speed and quality objectives of our partners. So to me, that is the biggest shift, is just not so much, I'm not saying forget about design. I'm not saying just ignore poor design practices. But it has to be balanced out with what your business, what your partners are trying to achieve. And so that isn't always an easy transition to make.
Yeah, I would say too, it's only become even more important in the age of AI. There's a big gap between reality and marketing in regards to like what's possible. And then you layer on top of that all of the complexity that you talked about and how you enable that for business teams. I think that there is, for better or worse in some ways, a slight erosion of some trust between the business teams and like engineering teams, because there's a slight perception that we should be moving faster than we are. Like AI has been here for several years. Why aren't we getting outsized outcomes? Why does it feel more or less similar to what we had some time ago? And so I think that getting to that predictable execution that you're talking about is one great way for us to continue to start to weave in these practices. Like you mentioned, over years, you evaluate those practices and improve in that delivery. And so really thinking about it from a perspective of, we're here to serve the business. We want to create a great experience for our customers and for our company. We want to create a great partnership with the people who are out there trying to make those things a reality for our customers. So continuing to push on that, I think is super important, Alex. So look, actually, yeah, go ahead.
I have to always remind my business partners that we don't only have to rely on AI. We have to be able to explain why AI did this or that, and that is sometimes challenging.
Yeah, if you're trading speed for like downstream reviews, more inconsistency, more security concerns, you're not really getting a lot of uplift from AI, right? So if you're going to implement it as a component of your execution, it's got to be thoughtful, and it's got to be not in the context of an individual person's context or their experience, but like your entire company, your organization, policies, procedures, and governance, the things that everybody that actually a human operator to your company is thinking about, should be thinking about when they're building systems for your customers customers and for your company. I was going to do a little bit of demos for us today. I think we're at the end of time. So what I'd actually like to do is just close out with a couple of things. Alex, first of all, thank you. This has been a grounded and honest discussion about what it actually takes to operate cloud engineering at scale. I really appreciate you for bringing your perspectives. I think for me, what stands out is that the challenge isn't just the lack of standards or a lack of architectural maturity. It's the difficulty of executing consistently in complex regulated organizations where every change crosses teams and controls and environments. So the shift that you described from sort of that expert-driven execution to standardized platforms and now toward controlled automated execution is kind of the real maturity curve to be able to deliver those outsized outcomes for our business partners in these ecosystems. And for the product that we're building, and I will just throw this up on the screen, infracodebase.com, that's exactly the problem space that we're focused on with the product. Not redefining architecture, replacing that engineering judgment. You remember keeping your hands on the wheel and making sure we're always in control, but making standards executable and translating those into governed, repeatable, and auditable actions across hybrid environments so teams can move fast without increasing risk. It's a super important topic, and it's kind of, to me, almost the next wave of like what internal developer platforms are going to become. AI assisted, but grounded in your organization with humans at the wheel and making sure we can deliver those outcomes with that technology. So it's really, really great. Alex, thank you. And for leaders in the audience, the takeaway for me is pretty simple. Cloud success at enterprise scale is an execution discipline. The organizations that win are the ones that make execution predictable. Again, Alex, if you want to connect with you on LinkedIn and learn more about you, or just be able to talk to you later, what's the best way for them to get a hold of you?
Probably just through LinkedIn. I think you just put my profile in there. So yeah, feel free to contact me through LinkedIn.
Yeah, I would encourage everybody to do it. In fact, it's so important. I'm going to flash it up again just in case you didn't see how the 00A0151 right there at the end. Connect with Alex. Alex, thank you again for sharing your experience and perspective. We appreciate the time and the candor. This has been great.
Thanks a lot, Justin.
Thank you, everybody.
Thanks.